Inequalities with negative coefficients. I think this lesson's coming just in time. I think we need a review of how to solve and graph inequalities, and with it we'll also kind of add in this idea of negative coefficients, which we have talked about with one problem set, one question. It did show up, but now we'll get a little bit more into it. Here's the bottom line with today's lesson. It's this rule that we kind of got to memorize. Let's go ahead and write this down and I'll explain. When multiplying or dividing by a negative, we need to flip the inequality. Okay. Let me give you a little example of why this is true, but I think we can all agree that 8 is greater than 5. Nobody's going to argue with me on that. 8 is greater than 5. Now with equations, you can do anything you want to both sides, or as long as you do it to both sides. The same is true with inequalities, with this one little kind of hitch. So if I want to multiply this by a negative 1, I'm going to multiply both sides by a negative 1. I'll get negative 8, and I'll get negative 5. Now which one is bigger? The negative 5 is bigger. So look what happened. That inequality flipped around. And that's always going to happen here. Always going to happen. Okay, so let me show you what we mean by solving inequalities. And I've got 4 examples. One where it starts off as less than, one that starts off as greater than, one that starts with less than or equal to, and one that starts off with greater than or equal to, so we can see all the differences in graphing as well. So we get a multi-step inequality here. Multi-step meaning I'm going to do 2 things. I'm going to add 6 to both sides, so I can get negative 5x is less than negative 1. I'm sorry, 5. And then I'm going to divide both sides by a negative 5 to get rid of that negative 5 coefficient there. And that's going to give me x is greater than negative 1. That is the inequality. So look what happened. I added 6 to both sides. Nothing changed with the inequality. I divide both sides by negative 5. That's when I need to flip the inequality. So whenever you multiply or divide by a negative number, you have to flip the inequality. There's the solution. Now I'm going to graph this solution. So greater than symbols are open dots and an arrow to the right. Okay, so some people are confused about why it's an open dot, because negative 1 is not one of the solutions, actually. Negative 1 is not greater than negative 1. So that's why we use an open dot. However, everything to the right of it is, like negative 9/10. Negative 9/10 is greater than negative 1. So as close as you can get to this negative 1 without actually being negative 1, those are all your solutions, and everything to the right of it. Okay, we get another one. Oh boy, this time we got variables on both sides. See that 7x and that 8x, okay? Well, you guys learned how to do this even in 7th grade with equations, and now we're just doing inequalities. So I want to get this 8x, all the x's moved down to the left side. So I can do that by subtracting 8x from both sides. That'll cancel out the 8x's on the right, and on the left I've got 7x minus 8x is negative x. So here's my new inequality. 7x minus 8x is negative x. We got the plus 2 less than or equal to 4. Now I'm going to subtract 2 from both sides so that I can get rid of that 2. And I'll get negative x is less than or equal to 2. Now I have not flipped the inequality yet because I haven't multiplied or divided by a negative number, but now I am going to. I'm going to divide by negative 1 on both sides. So that's going to give me x is greater than or equal to negative 2. And that's the solution to my inequality. So as soon as you divide by that negative number, you got to flip the inequality. Here's what the graph of that looks like. Got negative 2 right in the middle, and I'll just kind of scale this. Got a closed dot on negative 2, arrow to the right. It's still greater than, so the arrow still points to the right, but this time negative 2 is one of my solutions. So I color in that dot, as opposed to the last one where negative 1 was not one of the solutions, so I didn't color in the dot. Negative 2 is greater than or equal to negative 2. Do another one here. So I got variables on both sides, and I got some simplifying that needs to take place on the right. So that's what I'm going to take care of first. I'm going to distribute that 5. There's other ways to do this, but this is the way I'm going to go. So I've got negative 5x plus 25 is greater than 5x minus 25 when I do the distributive property. Now I want to get this 5x, or all the x's, moved over to the left. So I'm going to subtract 5x from both sides. The reason I'm doing that is because it'll cancel it out over here. But whatever I do to one side, I have to do to the other. So I end up with negative 5 minus 5 is negative 10x, plus 25 is greater than negative 25. There's my negative 25. Then I want to get rid of this 25 over here so I can get the negative 10x by itself. So I'm going to subtract 25 from both sides. That'll give me negative 10x on the left is greater than negative 50 on the right. Negative 25 minus 25 is negative 50. And then lastly, I'm going to divide both sides by a negative 10 so I can get x by itself. X is less than 50. Negative 50 divided by negative 10 is 5. And notice I had to flip the inequality because I divided by a negative number. You only do it when you divide by a negative number. And here's my graph. I got an open dot at 5 because it's not or equal to, and then everything to the left. These are the numbers that are less than 5. One more. Some distributive property there on the right again. So I'm going to distribute that negative sign, or multiply everything by a negative 1. So I'm going to get negative 2x plus 3 is greater than or equal to negative x plus 7. Negative 1 times x is negative x. Negative 1 times negative 7 is positive 7. Now I'm going to move all my variables, all my x's, over to the left side by adding x to both sides. Negative x plus x is 0. And negative 2x plus x is negative 1x, or negative x. So here's my new inequality. Negative x plus 3 is greater than or equal to 7. Now I'm going to subtract 3 from both sides so I can get negative x by itself. I get negative x is greater than or equal to 4. And lastly, I don't want negative x, I want positive x. So I'll just divide both sides by a negative 1, and I'll get x is less than or equal to negative 4. So that's the point where I need to flip the inequality because I divided by a negative number. If I divided by a positive 3, for instance, I wouldn't need to flip the inequality. So do we color in the dot or not? Yes, we do, because it's or equal to. And then show all my values to the left. As far as the scaling on your number line, you could use anything you want as long as it's equal scaling. I could say negative 3 here, negative 5 here. It would really be no different. I just kind of like to change up my scales every once in a while. Okay, so that's it on inequalities. This lesson is less than 8 minutes long. So if I went too fast for you, definitely go back and rewatch any of the examples as many times as you need to. I'll also be available for your questions in the morning or during class. See you then. Bye.